Okay, if we move into what you might consider another aspect of landscapes, which would be how do you actually represent landscapes? This is, of course, one of the major areas in geography and has been for the last couple of thousand years, and that's basically maps. Maps are conceptualizations or representations of concepts, most usually space. Can be physical spaces, can be human spaces, whatever it is. But maps are basically representations, and you're, even in a digital form, maps are two-dimensional representations of reality. So therefore, they're fraught with a whole set of sort of complex problems that the people, for some reason, just generally just don't seem to think about very much, which sort of amazes geographers to no end. Most one that's the most important to remember about that is that all maps are artificial, all maps are biased. Maps don't represent reality in terms of accurate. They're always inaccurate. If they represented reality accurately, they'd be the same size as reality. They'd have all the same information on them, and they don't. Now, till 20, 30 years ago, maps were physical. You drew them on pieces of paper, parchment, or whatever, and you basically drew out a map. And, and you can, I've got tons of them here in the office. You can find them everywhere. These are paper maps. And that, when you think about it, has a whole set of conceptual limitations. You've got to fit it on the piece of paper. So, for example, if it's going to be a regular 8x11 sheet of paper, well, what's that going to include? What's it not going to include? Till recently, it couldn't be in color. So that means that if you're going to represent things like trees or the shape of the land or water, how do you do that if you've got to do it with drawn lines and you can't actually use colors? If you've got colors, which colors do you use? So, cartography, which is the drawing of maps, is an art form. I remember the cartography class I took, in the doctoral program, was done by a superb cartographer. He did beautiful maps. In fact, most of the maps you see in Hawaii, for example, even in tourist brochures, are maps that his company up in Manoa made. Manoa Maps, I think they're called. And they were, that was a really eye-opening class in terms of realizing how difficult it is to make a map. Because both as an archaeologist and also as a geographer, I use maps all the time. In fact, the major Chinese project we've got right now is transferring paper maps from the Chinese archaeological, atlases into digital form in Google Earth, which we'll probably see later in the semester. So I'm, intimately familiar with all sorts of aspects of maps, but you don't tend to understand how hard it is to do a map or to do cartography, the drawing of maps, until you have to do one. Because you have to remember, drawing a map is easy. Drawing a map so someone else can understand it without you there to explain it to them is really tough. And that's why cartography is both an art and, to a certain extent, I don't want to call it a science, but it's very sophisticated in terms of how it does things. Even things like such simple things as lettering, colors that you use, the type of drawing in terms of the materials, the types of ink, the size of the lines, all this stuff is just incredibly complicated. And then this is why, good cartographers are seen as artists, and old maps, especially beautiful old maps that were done maybe a couple hundred years ago, were actually considered even back then as works of art. I mean, on one hand, they're informational. They told you things you needed to know, but they were also considered to be, the equivalent of a work of art, of a painting or something like that. And then even today, you see old maps that are, beautifully done are worth as much money as a famous master's painting. And, and in my view, that probably should be worth that much. They're astonishingly good. And you also see a ton of maps around here, especially say in tourism brochures and stuff like that, or say now online, that are absolutely crappy. And they're good examples of bad cartography. So that's the drawing of maps. And all maps, even digital maps like we're going to see now, are two-dimensional. In the modern concepts of maps, one, you can have them slightly animated. You can have them, artificially look like they're looking at elevation. You can have all these things that we think of as actually mirroring reality, but they're still artificial, which is why you still see people getting stuck on trails around here because they've been trying to follow where they were going on Google Maps. And they got lost. Well, in many cases, they got lost because they couldn't read the map, which is pretty pitiful. But in other cases, they got lost because the map's inaccurate. Google Map was never intended to be used to hike trails. It's not that accurate. So if you follow it, to the letter, if it says, the trail goes this way, and you don't watch where you're walking, you just follow what's on your phone, boop, you're going to go over the edge. And in my view, you should. Maps can never be taken literally. Maps are never accurate. Maps are always inaccurate. They always reflect the bias of the people that made the map, if you would, the cartographers. So if you're using Google Maps or Google Earth, and I've worked with the Google Earth folks, you're looking at the biases of the Google Earth or Google Maps cartographers. The fact they're so usable is good, but they're not reality. They're always constructs. They're always mental images, if you would. They're two-dimensional images of landscapes, put on by someone who's in one shape or form, sort of an artist. Map projection is the way that you then project a landscape. So if you think about it, if you're going to draw from, say, here I'm in my office on campus, if you want to draw going down to Market City, the shopping center down the street, then you're going to put that on a flat piece of paper. You have to decide what's important. Well, if you're trying to tell students how to get from, Lokalani dorm to Market City, okay, fine. That sort of tells you the boundaries that you have to include on a sheet of paper. But how are you going to do elevation? Is the distance they have to go up and down important? Most students get pretty grumpy when they realize they have to walk up the hill all the time. Is the type of road that they've got to walk on important? And do you have to put, for example, what's available at Market City? You start to think of all this on an 8x11 map, and all of a sudden the map gets really messy, especially when you have to be able to give it to someone and they can immediately figure it out. You don't have to sit there and stand on their shoulder and sort of say, well, because they're going to forget the minute you walk away anyways. So making a map projection is figuring out how you turn three-dimensional reality, which in the case of this campus is very much all over the place, onto a flat sheet of paper. There's all sorts of standardized ways we do this with topographical representation, et cetera, that you'll see with topographic maps. But they're all, again, artificial. And again, they're all at the cost of something else. If you put this on, then you can't put something else on because all of a sudden the map will just be a blob of black. So map projection is, again, the way that these are done. If you want to see a classic example, think of, go to like my intro geography, the World Regional Geography class, and you have a flat map part of the world. But of course, the world is a sphere, and it's not even a good sphere, it's an oblate sphere. So, if you have a map of, for example, the entire planet squashed down two-dimensionally, if you think about that, it's like taking an orange or a basketball and somehow squashing that sucker down flat and trying to make it still look round. It's not, it's going to be all distorted because you've taken a three-dimensional spherical object and you suddenly try to make it two-dimensional. This is what we call map projection, and Short has a pretty good discussion of the different ways that you do map projection. And again, they're standardized ways, and they're really important because if you look at these, as most people do without thinking about it, if you look at a map of the world, the sizes in terms of the size of continents and even the position of continents is totally distorted because you've taken a sphere and you've squashed the puppy. So map projection is not really that important to geographers in the sense that geographers know what the projection is, but to non-geographers, it's hugely important because it can massively misrepresent the size and actual location of things relative to each other. And depending on what you're trying to do three-dimensionally, that you now squashed into two dimensions. Map bias, that we've already covered that's the fact that you always have to simplify stuff. Mental maps, of course, are the images that we carry in our heads. An example this morning, I was trying to explain to some of the new students how to get to Market City. So what you have to do is in your head, you're actually visualizing, okay, here I am on campus, and you go this, you do that. So you visualize the path that you take to get to Market City. That's a mental map. So we all have mental maps of places. And when we don't have mental maps, of course, we frequently get lost. Of course, even with a mental map, I suppose you could get lost. So mental maps are the images that we carry in our head of the world around us. And as with everything else in geography, they're subjective, they're personalized, and they tend to reflect our view of the world around us, not necessarily the reality of that world. Okay. So it's important to remember mental maps are hugely important to geographers when you're talking to folks in a particular place. If you want to know, going back to the idea of space and place, if you want to know what places people carry in their heads or in their hearts or wherever it is, ask them how to get to some location. In the process, they're almost invariably going to define that mental map they've got by virtue of particular places. And if you talk to 10 people and they're from different backgrounds or different whatevers, you're probably going to get 10 different lists of places, even if you're starting at the same point and you're ending at the same point, because they're going to have different ways of, they've looked at the world differently. They judge the importance of things differently, and that's going to be reflected in the mental maps and the way they orient themselves in the world. And that's tremendously useful for geography. And again, if you think about it, that's sort of what we're looking at in Second Life too a little bit. All those places there are a reflection of what you might call people's mental maps in part, because they put them there and they've put them in reference to other things around them, the houses next to them or the hill or whatever it is. So mental maps are a big part of what especially geographers like me do, because my specialty is ritual or symbolic, or if you want to, religious place. And obviously mental maps are absolutely key. If you think again, those Japanese shrines that I showed you 2 episodes ago, those little Japanese shrines are reflective of mental maps that people have of that landscape, because they see the landscape as having spirits in them. The spirits, just for your own information, are usually based in trees or water. So it's a good bet that those little shrines were tied to those trees that they're wrapped around. And that's really important to Japanese. Doesn't make any sense if you're not Japanese and not into Shinto, but it does if you are Japanese and you are into Shinto. That's where the kami, where the spirits reside. And that's going to be the way that you look at the mental map. Your landscape's going to have things that where spirits reside, and that's going to be part of the way that you locus things, is those particular places are going to be defined by spirits, and the objects they represent, trees, water, whatever. Very different view of mental maps than Americans, who see trees as, you know, something you cut down to make logs that you buy at City Mill or Home Depot. Okay. Last of these are the impacts of what we call GIS, GPS. GPS, you're familiar with, your phones all have it. If you want to do something sort of creepy, and I have this simply because I work with the Google folks, you can, as an option in Google Map, you can actually set it so it will keep track of where you've been. Actually, it does this anyways. And then once a month, they'll actually give you a report that shows every place you've been, because it keeps track of where your phone is all the time and how long you spent there. And Google just collects all this data automatically. They're not even thinking about it. They use it, they sell it. But it's sort of surreal when you actually get a report back from a company that says every place you've been, how long you've been there. And it compares it from one month to the next. That's GPS systems. The process of mapping where I've been on that landscape is what we call part of what we call geographic information systems. So let's stop the share and switch over, and we'll walk into this. Hang on a second. Okay, here's the geographic information system I use. There's one that is in common use by professionals. That's called ArcGIS through Esri. That sucker is incredibly expensive. And I actually am not a fan of it. I mean, I use it. I know how to use it, but I don't like it. And I think because it's not very accessible to everyone, you get them as static maps. It's not particularly dynamically useful. On the other hand, Google, right from its get-go, has been, everyone can use this all the time. Google Earth is a more sophisticated version of Google Maps. So if you want to think of Google Maps as a stripped down version of part of Google Earth. So Google Earth is a geographic information system. Okay. So if you see this, what you've actually got here, I'm assuming, yeah, shows up to you. What you've got here is the typical parts of a geographic information system. Now, when you think about it, this is still a map. Okay. Now, in this case, they've actually overlaid satellite imagery. So it looks like a picture, but of course, this was taken in 2021 from the LDO Columbia satellite. So this is actually a snapshot. It's not dynamic, and it's not now. It's from probably a couple of months ago. So here what you see is this. Now notice I can move it around. Notice how it's also got the ocean. But again, notice how this again is representations or interpretations. It's not the actual ocean for it. It's these images of it. And you, of course, can zoom in. Now, what you've got and what makes geographic information systems key is not so much this. You could do this on an original, map 100 years ago with a photo overlay and doing artwork on it. But what makes these really key is the fact that it's got all these layers. So if you think of this, it's got like a bunch of digital, or if you want to think of the old style plastic, mylar layers. Now this is all digital. It's just got stacks of different types of information that you put in, and then you can either put them on top of each other or you can replace them. So for example, we'll put this one in. Now, this is part of our Palolo Pukele project. Okay. And we've inputted this. This is all the land map awards for folks claiming land back in 1848 through 1852 during the Mahele. So in the sort of early middle period of the monarchy, This is all the plots of land for this part of the island of Oahu that were claimed by people for either houses or for farms or whatever. So that's one layer. And of course, we can take that off. We can put the names of all the people that made the claim. So this includes not only the names, but also the claim number. And then we can add that to the locations. So if we zoom in, we've actually got both the locations and also whose claim that is for that piece of property here in the beach of Vaititi, as it used to be called. Now, since it would also be useful, we can also add the actual stream flows. So I think of it now, and of course, you've got the combined Manoa-Palolo stream goes roaring down past the Ilani School and goes smack into the Alawai Canal, which you can see here in this image. If you look at it in the blue, that's actually the complex of streams that existed prior to that tremendous amount of effort they put in the early 20th century to basically control the stream flow, which has been a pretty, abject failure, to be honest. But here you see Manoa Stream used to be over here, and it actually only part of it hooked into Palolo Stream, and it went through all this area. This whole area of Vaititi was basically dalo patches and fish ponds, which is one reason why it floods so easily. Which is why the flood control project that they're spending billions and billions of dollars on is going to be an abject failure, because the physical reality is this part of Waikiki is only about 3 feet above sea level. So no matter how much you try to keep it, the minute any water come down here, it's eventually going to flood this, because guess what? It's at sea level. Water goes downhill. So if you went back into 1848, this is what you would have seen. There was no Alawai, there was no stream here. There was a network of streams, and people were using that streams to put in planting. Now, if you think of our idea of cultural landscapes, then you can also see then the change in the cultural landscape of this part of Vaititi. This used to be an incredibly, look at all the little network of different types of little farms and fish ponds and stuff that people had in here. When this was all low, so these were all fish ponds here. All these very small little pieces where people were growing something, in most cases probably dalo, but also yams. A lot of these would be like small, like tilapia type fish ponds for moi and stuff. So what you've got are all these different areas, and now what you've got is a golf course, and you've got a channeled concrete structure and a drainage system that leads off into there. So this landscape has just changed almost. It's almost impossible to see any of the landscape. If you go through this part of Vaititi, and I know because we walked it, you see absolutely nothing that gives you any hint of the world that just existed only 150 years ago, because all this was pretty much intact in the 1860s, 1870s. It's all gone. It's been completely overlaid by the New World. This is certainly true down here in Vaititi proper, which again, you see nothing left of these. These all had walls or some sort of markers to tell it's my property versus your property. It's all gone. Now, what you'll still find is frequently, if it floods heavily, you will find that, for example, down here around Apuakahau, which was used to be a very powerful religious site, it was a heiau here. What you'll find is it'll still, if the water gets really high, you'll still see water, coming down here sort of off the street at this location. Why? Because this spot's still a little lower than the area around it. And that old stream bed still is an area where water wants to go because it's a little easier for it to go there. So on one hand, you have all the construct of modern Waikiki. On the other hand, that doesn't mean all this is necessarily completely disappeared, though ironically, the human world has changed completely. So this is a geographic information system. You can add material to it. You can take things off. And each of these, if you notice, are layers. And that's what you do with geographic information system. This allows you to have an enormous amount of information. And when you think about it, if I put all this stuff in here, let's click on everything, pretty soon you got this whole thing is just swamped. You can't make sense of it because there's just too much information. And that, of course, is the problem that cartographers has always had. Now, you can cheat to a certain extent with geographic information systems. You can change the zoom, so you can make it smaller, or you can just, delete things because I can't get hold of what it is I want to look at. If I want to look at where the water used to flow, then I don't need those other things. So this is what you guys are used to working with. You're used to working with geographic information systems. Google Maps is a baby step version of Google Earth. It's designed for phones. You can do Google Earth on phones if you've got an Android phone. I assume with an Apple phone, I'm not that familiar, but But with Android phones, you can put Google Earth on, but trust me, you know, if you got your phone out, if I got my Samsung out and I laid all the sucker on there, you know, all I would see is a blur of pink and blue. You know, even if you zoom in, it just phones have a really hard time dealing with this level of data. But on the other hand, if you're looking at our project, which is looking at the whole relationship that all of us have with Palolo Stream all the way down to the LOI, or more accurately to ITT, then you need to have all this information because it gives you a much better idea of how this place was. And in fact, if you see this, just to give you an idea of the value of maps, notice how this whole area was very, very heavily planted. There's a ton of little tiny farms in here. There's a ton of little tiny farms in here, but what you notice here that's really striking is all of a sudden the farms stop. Now they do for two reasons. One is the high chiefs claimed some of this property. Keoleana was the governor at the time. But on the other hand, what it also says is that individual, that common alliance, for one set of reasons or another, didn't have access to this property. It's very possible the section over here, because it's too far away from the stream, was maybe too dry for a lot of agriculture. If you notice, everyone here is intimately tied to this stream. The stream allows them to survive. Stamen VTT. People are near the water. The water is what you need if you're a farmer, and near the water, to do good. Far away, you don't have it. Again, notice the lack of people here. So this is a geographic information system, and this is how geographers, this is a lot of what we do. And it's this mainstay of much of geography in the 21st century. It's what I'm doing both with this project and also with the China project.